Welcome to my channel, and what I want to do here, I want to show you how to solve this particular problem, this particular question 15, which has to do with the construction of a cycloid. So I'm going to read the question for you to understand what we are to do with it. And the question says that a circle of 50 millimeters diameter rolls along a straight line without slipping. Draw the curve traced out by a point P on the circumference for one complete revolution of the circle. Name the curve. And we also have another sentence here that says that draw a tangent to the curve at a point on it 40 millimeters from the line. As I said, this question has to do with the construction of a cycloid. So the diameter of the rolling circle is 50 millimeters. So we have to bear that in mind. And then we're asked to name the curve, and also we are to draw a tangent at a point 40 millimeters from the line. So let's see what we are to do with this particular problem. So what we need to do first is to draw a horizontal center line like this. Okay, and then we are to draw a vertical center line. So we have to draw a vertical center line. So we're going to draw it. So here, like this. Alright, so having drawn these two lines, the next thing that we are going to do is to take the radius of the rolling circle. So diameter is 50, so the radius will be 25 millimeters. So we take a measurement of 25 millimeters. So we put at this point and we draw a circle. Alright, so that is the circle that we have drawn. So we have to divide this circle into a number of equal parts, that is into 12 equal parts. So we divide the circle into 12 equal parts. Alright, so the circle has been divided into 12 equal parts. So the next thing that we are going to do is to number the points on the circle. So this point is point 0. So the movement starts from this point 0. Then we have 1, we have 2, this is 3. So this is point 4, this is point 5, this is point 6, point 7, this is point 8. So this is point 9, this is point 10. And this is point 11. Alright, so having done this, the next thing that we are going to do is to draw a horizontal line from this point. So we draw a horizontal line from this point here, like this. Also from this 2 points here, so point 1 and 11 are the same point on the circumference of the circle. So we draw a horizontal line here. Point 2 and 10 are the same point on the circumference of the circle. We draw a horizontal line from here. So we have drawn that of 3 and 9. So then that of 4 and 8. So we draw a horizontal line from here, like this. Then point 5 and 7, they are also at the same point on the circumference of the circle. Here we draw a horizontal line. And point 6, we also draw horizontal line from this point. Okay, so having done this, the next thing that we are going to do is to calculate the circumference of this circle. Calculate the circumference of this circle. So if diameter is 50, so what will be the circumference of the circle? So all you need to do is to multiply 50 by 3.8 142, which is the value of pi. So so as I'm going to do it here, we have 3.142 times, so 142, so times 50, and that gives us 157 millimeters. 157 millimeters. So I'm going to take a measurement of 157 millimeters from this point 0 here. So 157 millimeters. So this is my 157 millimeters here. Now, so the next thing that we are going to do, this 157 millimeters that we have taken, we are going to divide it into 12 equal parts, as we have divided this circle into 12 equal parts. So I'm going to do that right now. So from this point, I need to draw a line in this direction. That is from point 0. So I need to draw that line. So then I'm going to make 12 points on this line that I just drew. So this is okay. Alright, so this is 1, this is 2, so this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. Okay, so that's complete. So then I'm going to join the last point with the end where I have that 157. Okay, so the next thing I'm going to do, which I believe you know how to do, so I'm going to draw parallel lines to this line. So I need to make use of my set square to do that. Okay, so setting this line at this point, this set square at this point along this line. So I will shift to the next point like this, and then I will draw this line. Okay, so to the next point, so I'll draw the line. Next point, I will draw the line. So next point, so I'll draw the line. So next point, so I'll draw the line. Okay. Alright, so this is the last one. So we have divided the line into 12 equal parts, as the circle was divided into 12 equal parts. So the next thing that we are going to do, I need to extend this center line a little bit. Okay, so the next thing I'm going to do is to number this point. So this is point 1, this is point 2, this is point 3. So this is 2, so this is point 3, so this is point 4, this is 5, this is 6, 7, 8, this is 9, this is 10, this is 11, and then back to 0, so making it 12 like that. So the next thing I'm going to do is to erect a perpendicular line at each of these points. So this is what I mean. So you draw a vertical line here. So at this point 2 here, you draw a vertical line. At point 3, you draw a vertical line. So at point 4, so draw a vertical line. At point 5, draw a vertical line. So at point 6, draw a vertical line. At point 7, draw a vertical line. At point 8, so we draw a vertical line. At point 9, draw a vertical line. At point 10, draw a vertical line. And at point 11, draw a vertical line. So last point is point 0 here. So draw a vertical line here. Alright, so now, so the next thing to do is to make this line. So you make this line this line will make it a thick line. I mean this line 0 0, because it's upon it that the circle is rolling, just like a tire is rolling on the surface of the road. A car tire is rolling on the surface of the road. So we need to make this line a thick line. So it's upon it that the circle is rolling. So it has to be made thick, as I've done it here. So the next thing that we are going to do is to locate the point that we are going to use to generate the curve. So that is what I'm going to do next. So I need to, okay, alright, so then we need to take the radius of this circle, so which is 25. So I still have the radius here. So now, so I need to do something here before I go. So this center here, this is center 1. This center is center 1. This is center 2. I mean this point here. So why this one is center 0 here? So this is C0, this is C2, this point here. So this is C3. So this is C4. So this is C5. This one is C6. This is C7. This is C8. So this point here is C9. So this is C10. So this is C11, and here is C0. So those are the centers of the center that we are going to use to generate the point. So with 25 millimeters, the radius of the circle, I will put at center 1 like this, and I make an arc here. So on line 1, so this line 1 here, so I make an arc on line 1. So then I put at center 2 here. Center 2, I make an arc on line 2. So here we have 2, okay? So then putting it at center 3, I make an arc on line 3. So this is line 3, so the center line. Then putting it at point 4 here. So I make an arc on line 4. Then putting it at center 5, I make an arc on line 5. So then putting at center 6, so that will touch the last line, so we should be at this point here, sorry, so to be at this point. So this is it, just touch this line, so the last line, which is on 6. Then I'll put at center 7 here, so make an arc on line 7, so that is the same line with 5. So then putting at center 8, so I make an arc on line 8, so that is the same line as that of 4. Then putting at center 9, I make an arc on line 9, which is also the same at line 3. Then putting it at 10, so I make an arc on, this is line 10, so which also contains 2. Then putting it at center 11, so I make an arc on this line, is also the same as that of 1. Okay, so all these points here, so I'm doing it with 0 here. So all these points that we have obtained here, so all these points, we are going to join them together with the use of a French curve. All these points, so I'm trying to make sure we can see those points. Alright, so all these points, we are going to join them together with the use of a French curve. So I have my French curve here, so I'm going to join. So that is the curve. Okay, so this curve is what we call cycloid. This curve that we have obtained is what we call cycloid. So another thing that we're asked to do is to draw a tangent to this curve at a point 40 millimeters from this line. So this is the line they are talking about. So what we need to do is to take a measurement of 40 millimeters from this point up. So this is 40 millimeters. I'll take 40 millimeters like this. So this is 40 millimeters here. So what I need to do now is to ensure that I get that line on the point. So from this point here, so I will just draw a line like this to touch the curve. So it touches the curve. Okay, so it touches the curve at this point. So this is the point here. Okay, so this is the point. So I will call this point, I will call it point P. Okay, we'll call it point P. Now, having located point P on the curve, so the next thing to do is to take the radius of the circle, which is 25 millimeters. So put the midpoint here at point P here, and you draw an arc on the center line. You can see it on the center line. So wherever it touches on the center line, so let's call this point, let's call it point Q. So let's call it point Q here. So this is point Q. So now next thing to do is that, so you draw a vertical line from point Q. So draw a vertical line from point Q down to the line. So let it touch the line. So let's call this point, let's call it point R. So this point, let's call it R. So from R now, so now draw a line through point P on the curve. Is it? So draw a line through point P on the curve. So from P up here, so I'm going to, so I'll call this line, so I'll call it line PS. So this end of the line is point S on the line here. Okay, now so having gotten this point, so let me write it here, that from here to here, so from here, from P to Q, so line PQ is 25 millimeters. Line PQ is 25 millimeters, which is the radius of the circle. So now this line PS is a normal line. So then I'm going to draw the tangent. So to draw the tangent, I need to make use of my protractor. So I will set my protractor on this line PS and ensure that I can see the point. Just make sure that 90-degree line is on line PS as I've done it here. So ensure you have something like that. So then I'm going to draw a line, so through this point like this. Okay. Alright, so that is the tangent. So I can call this tangent, let me call it line AB. Let me call it AB. So that is the tangent. So this is how to construct a cycloid with the value that we are given for the diameter of the rolling circle, and also for the point at which the tangent touch the curve. So as I have said, so this curve is known as a cycloid. Thank you and keep on practicing. God bless you.